Some worlds vanish not because they were destroyed, but because they were forgotten. 300,000 years ago, when Homo sapiens first appeared, Earth was colder and wilder, with glaciers slowly shaping the continents. Giant herds ruled the plains, while humans were just a small part of Earth's history. What did the first world Homo sapiens saw really look like? We often imagine that Homo sapiens emerged on an Earth that had already settled into stability, then gradually set out to conquer it. Yet the evidence from geology, climatology, and paleoanthropology tells the opposite story. Around 300,000 years ago, when the first modern humans appeared in Africa, Earth was still a planet in constant transformation. Its climate, rivers, forests, grasslands, and even the migration routes of animals were continually shifting. Most remarkably, the force that set all of this in motion did not originate from life itself, but from Earth's own journey around the sun. Scientists call this mechanism the Milankovitch cycles, a combination of three astronomical variations. Changes in Earth's orbital eccentricity, the tilt of its axis, and the slow wobble of that axis over time. Each cycle alters only a tiny fraction of the solar energy reaching Earth. Yet over tens of thousands of years, those subtle changes can determine whether colossal ice sheets continue to expand or begin to melt. When combined with natural feedback systems, such as ice cover, atmospheric carbon dioxide levels, ocean currents, and vegetation, these seemingly minor variations can drive the planet into ice ages or prolonged warm periods lasting tens of thousands of years. One of the clearest examples is the Sahara. Today, it is the world's largest hot desert, spanning more than 3.5 million square miles. Yet during multiple phases of the Pleistocene and the early Holocene, this same region was a vast green landscape filled with rivers, lakes, grasslands, and wildlife, including hippos, crocodiles, elephants, and giraffes. Fossils and ancient rock carvings scattered across what is now barren desert reveal that humans once lived, hunted, and even traveled by boat across waters that vanished long ago. When the climate became wetter, the Sahara transformed into a massive ecological corridor stretching thousands of miles, connecting North Africa with the rest of the continent. But when arid conditions returned, it became an immense natural barrier, forcing both humans and animals to alter their migration routes. In East Africa, where Homo sapiens first emerged, the landscape itself was equally dynamic. The formation of the Great Rift Valley, a system of fractures extending more than 4,000 miles across eastern Africa, continually gave rise to volcanoes, new lakes, and ever-changing grasslands. On a global scale, immense ice sheets repeatedly advanced and retreated. Forests gave way to grasslands before returning once again, while vast herds of large animals constantly followed shifting sources of water and food. Earth during this era was not a quiet, unchanging planet. It was a world in perpetual motion. And that was the greatest challenge Homo sapiens ever faced. In an environment that never stopped changing, strength and physical size were not the qualities that determined survival. Our ancestors did not evolve to become the strongest species. They evolved to become the most adaptable because long before humanity learned to reshape the Earth, it was the Earth that had been quietly shaping humanity all along. If a Homo sapiens living 300,000 years ago could see a modern map of the world, they probably would not recognize their own planet. Not because the continents were located in different places, but because coastlines, land bridges, and migration routes were constantly shifting to the rhythm of the ice ages. For humans of the Pleistocene, Earth was not a fixed map. It was a planet continually redrawn by a changing climate. During colder periods, millions of cubic kilometers of water were locked away in massive ice sheets across North America, Northern Europe, and Antarctica. As a result, global sea levels fell, exposing vast areas of land that now lie beneath the oceans. During the last glacial maximum, around 26,500 to 19,000 years ago, sea level was approximately 400 feet lower than it is today. This transformation created enormous stretches of land connecting regions that had once been separated. Shallow seas became plains, grasslands, and natural migration corridors, allowing both animals and humans to expand their ranges. One of the most famous examples is Beringia, the landmass that once connected Siberia and Alaska. Today, this area is the Bering Strait, but during the ice ages, it became a vast, cold plain with a dry climate and abundant vegetation. It was home to woolly mammoths, steppe bison, wild horses, and reindeer. This corridor later played an important role in the movement of humans into the Americas. Rather than crossing a vast ocean, ancient groups may have traveled across a continuous stretch of land linking the two continents. In Southeast Asia, a similar transformation created Sundaland. When sea levels were lower, the Malay Peninsula, Sumatra, Java, and Borneo merged into a vast expanse of land. Areas now submerged beneath the Java Sea were once broad plains crossed by major river systems, where elephants, rhinoceroses, and many other Asian animals could roam freely. However, not every sea disappeared. Between several Indonesian islands, deep straits remained submerged even when sea levels dropped by hundreds of feet. This region is known as Wallacea, forming the famous biological boundary between Asia and Australia. West of Wallacea lay the world of Asian animals such as elephants, tigers, and rhinoceroses. To the east was Sahul, the landmass that once connected Australia, New Guinea, and Tasmania, where an entirely different ecosystem evolved, dominated by marsupials and other endemic species. The arrival of Homo sapiens in Sahul around 65,000 to 50,000 years ago suggests that our ancestors had developed the ability to plan sea crossings remarkably early. They did not simply follow overland bridges, but also crossed stretches of sea that had never disappeared. In Europe, another remarkable example was Doggerland. This land once connected Britain to continental Europe, forming a vast plain filled with rivers, forests, and wildlife. Today, most of Doggerland lies beneath the North Sea, yet archaeologists continue to discover stone tools, animal bones, and traces of prehistoric humans on the seafloor. As the climate warmed after the last ice age, melting ice sheets caused sea levels to rise, submerging many low-lying lands that had once been home to human communities. Seen as a whole, the Earth of the earliest Homo sapiens was not a planet defined by fixed boundaries. Land bridges appeared and disappeared, plains became seafloors, and migration routes continually opened and closed in rhythm with the changing climate. To understand how humans spread across the planet, we must look at the Earth itself, because long before Homo sapiens explored the world, the planet had already been quietly opening the paths they would one day follow. As land bridges repeatedly appeared and disappeared with the cycles of the ice ages, it was not only Earth's map that changed. Entire ecosystems were reconnected as well. But if you could set foot on the planet around 300,000 years ago, the most astonishing sight would not be the different continents, but the creatures that ruled them. Across the cold grasslands, stretching from Western Europe to Siberia, woolly mammoths, standing more than 10 feet tall at the shoulder, and weighing up to roughly 17,600 pounds, migrated seasonally across vast territories. Living alongside them were woolly rhinoceroses weighing more than 4,400 pounds, steppe bison, and the giant deer Megaloceros, whose antlers span nearly 12 feet, making it one of the largest deer species ever known. In Africa, elephants, hippos, buffalo, giraffes, and many other large mammals formed ecosystems far richer than those that exist today. Mammoths and other large herbivores helped maintain grasslands by breaking down shrubs, dispersing seeds, and reshaping vegetation. Their presence determined where predators could live, while their bodies continued to nourish an entire network of organisms after death. Every species played a role within that enormous ecological system. But wherever large herds of herbivores gathered, fearsome predators followed. Cave lions were larger than modern African lions. Cave bears could weigh nearly 2,200 pounds, and cave hyenas possessed powerful jaws capable of crushing large bones. For Homo sapiens, these animals were not only threats, but direct competitors for food, shelter, and territory. In this world of giant creatures, humans possessed almost no physical advantage. We had no claws, no exceptional speed, and none of the raw strength of large predators or herbivores. An adult human weighed only about 130 to 175 pounds, tiny compared with the animals dominating the surrounding environment. So what allowed Homo sapiens to survive? The answer was not muscle, but adaptability. Archaeological evidence shows that humans did not compete with these giants through direct physical strength. They observed animal behavior, tracked migration routes, used stone tools, coordinated in groups, and took advantage of every possible opportunity to survive. Rather than becoming the strongest species, Homo sapiens became the species capable of using knowledge to overcome its own biological limitations. The harsh environment of the Pleistocene created intense pressure that encouraged planning, communication, and cooperation. In a world where a single mistake could cost a life, groups that shared experience and coordinated effectively had a greater chance of survival. But when Homo sapiens first emerged, Earth was still the kingdom of giants. Humans were only a small species beginning to learn evolution's most important lesson. The greatest strength does not lie in the body, but in the ability to understand and adapt. And it was this invisible power that would gradually transform the fate of a small species, and ultimately transform the entire planet it called home. After witnessing herds of giant animals dominating the land, we might assume that they were the defining image of Earth 300,000 years ago. But if we were to observe the entire planet from space, something else would stand out even more: the absence of humanity. There were no cities, roads, ships, or satellites. At that time, Earth still operated almost entirely according to the natural processes that had governed it for more than 4.5 billion years. Every change across the planet was driven by climate, the oceans, and wild ecosystems. When night fell, the sky looked completely different from the one we know today. With no artificial lights to obscure it, the Milky Way stretched brilliantly across the darkness. The earliest generations of Homo sapiens gazed upon an untouched sky, where they gradually learned to recognize the cycles of the moon, the changing seasons, and the migration patterns of animals, knowledge that became essential for surviving in the natural world. The atmosphere of that time bore no trace of civilization. There were no industrial emissions, plastics, or synthetic chemicals created by humans. Today, NASA satellites show that dust from the Sahara can travel more than 3,100 miles across the Atlantic Ocean, carrying minerals such as phosphorus that help nourish the Amazon rainforest. Beneath the oceans, Immense currents silently regulated the planet's climate. Changes within this system helped reshape rainfall patterns, vegetation, and animal migration routes throughout the Pleistocene. For the people of that time, every sound could carry the meaning of survival. A snapping branch or a distant noise might signal that danger was approaching. Within rock layers from this period, scientists find no concrete, synthetic plastics, refined metals, or traces of industry. They find only mineral dust, volcanic ash, pollen, and fossils, the enduring signatures of natural processes. It was a planet that had remained almost entirely untouched by human influence. Homo sapiens were not yet the dominant species, nor were they even the only humans alive. But their capacity to learn and adapt would gradually create a turning point unlike anything in the history of life. After learning that Earth around 300,000 years ago bore no trace of civilization, many people assumed that Homo sapiens was the only human species alive. But the reality was entirely different. When the first modern humans emerged in Africa, several other branches of the genus Homo were still living across the planet. They also made tools, controlled fire, hunted, and adapted to harsh environments. The dawn of humanity was not the story of a single species, but an era in which multiple human lineages coexisted. In the past, human evolution was often imagined as a straight line leading directly to Homo sapiens. But fossil discoveries and ancient DNA have completely changed that view. Human history is more like an evolutionary tree with many branches developing side by side, some of which disappeared while still leaving traces within our own genome. Ancient DNA research, led by geneticist Svante Pääbo, opened an entirely new era in understanding human origins and earned him the 2022 Nobel Prize in Physiology or Medicine. In Europe and Western Asia, Neanderthals, Homo neanderthalensis, were among our closest relatives. They possessed powerful bodies, were well adapted to cold climates, and had an average brain volume of about 1,450 cubic centimeters, or roughly 88 cubic inches, larger than the average modern human brain. Archaeological evidence shows that Neanderthals controlled fire, crafted stone tools, hunted large animals, cared for injured individuals, and may even have used simple jewelry or mineral pigments. They were far from the primitive beings they were once imagined to be. Farther east lived the Denisovans, a mysterious human lineage discovered through DNA extracted from a finger bone found in Denisova cave in Siberia in 2010. Although Denisovan fossils are extremely rare, their legacy remains within modern humans. Some populations in Papua New Guinea and Melanesia today carry approximately 3 to 5% Denisovan DNA. Most notably, the EPAS1 gene variant that helps Tibetan populations thrive in the thin air above 13,000 feet originated from the Denisovans. On the Indonesian island of Flores, Homo floresiensis, often called the Hobbit, also existed. They stood only about 3 feet 3 inches tall, yet still made stone tools and adapted successfully to life on an isolated island. In South Africa, Homo naledi surprised scientists with its small brain combined with evidence of surprisingly complex behavior. Some hypotheses suggest that they may have deliberately handled their dead inside caves, although this question is still being actively investigated. Perhaps the most remarkable discovery is that these human species were not completely separate from us. When Homo sapiens expanded out of Africa around 60,000 to 70,000 years ago, they encountered and interbred with both Neanderthals and Denisovans. Today, most people with ancestry outside Africa still carry about 1 to 2% Neanderthal DNA, while many populations in Oceania also retain Denisovan ancestry. These inherited genes continue to help modern humans adapt to certain environments. These discoveries reveal that Homo sapiens did not emerge into an empty world. We are the last surviving branch of what was once a remarkably diverse human family. And the greatest question still remains. Why, among all the human species that once lived on Earth, did only Homo sapiens survive? The answer lies not only in the body or the brain, but in the ability to cooperate, accumulate knowledge, and pass experience from one generation to the next. An advantage that would ultimately reshape the entire course of human history. During the Pleistocene, a single prolonged drought, a drying lake, or a shift in rainfall belts could transform an entire ecosystem. At that time, the most important question for both humans and animals was not who was stronger, but where water, food, and the conditions necessary for survival could still be found. Humans of that era were completely dependent on nature. When grasslands turned into deserts or dense forests became open savannas, herds of grazing animals immediately changed their migration routes. Homo sapiens could not force them to stay. They could only follow or face starvation. For this reason, many paleoclimatologists describe climate as the invisible architect of evolution. It did not directly create humans, but it continually determined where humans could live and forced populations either to adapt or disappear. The Sahara is the clearest example. During humid climatic periods, the region that is now the world's largest desert was once covered with grasslands, lakes, and rivers. Fossils of hippos, crocodiles, and elephants, along with thousands of rock carvings, reveal that it once formed an ecological corridor linking East Africa with North Africa. When rainfall declined in response to natural climate cycles, vegetation vanished, and the Sahara once again became an immense barrier. The routes that had allowed animals and humans to migrate gradually closed. That change alone repeatedly shaped the direction in which ancient human populations spread and became isolated. Data from Greenland ice cores show that temperatures sometimes rose or fell extremely rapidly over short geological periods, bringing changes in rainfall, vegetation, and the geographic ranges of animal species. Archaeological studies in East Africa, the Levant, and the Arabian Peninsula also reveal a recurring pattern. Homo sapiens populations often expanded during humid periods. When lakes were full, grasslands flourished, and large animals gathered in high densities. By contrast, prolonged droughts caused many regions to be abandoned and led numerous waves of migration to fail. This helps explain why not every group of Homo sapiens that left Africa produced descendants. Only populations flexible enough to adapt to unfamiliar environments survived and passed their genes on to the present day. To survive, Homo sapiens had to remember the locations of water sources, anticipate rainy seasons, track animal migrations, share information, and coordinate within larger groups. The ability to learn and pass down experience gradually became more important than physical strength. Before humans learned to reshape their environment, the environment itself had already shaped the way humans thought and acted. That process of selection, unfolding over hundreds of thousands of years, prepared humanity for the next great turning point: the vast migration that carried Homo sapiens out of Africa and across the planet. If there was one moment that changed the course of human history, it was not the birth of agriculture or civilization, but the day a small group of Homo sapiens left Africa and entered a completely unfamiliar world. Yet that journey did not begin with success. Archaeological evidence shows that Homo sapiens left Africa multiple times, beginning around 200,000 years ago. Fossils from Mislia Cave in Israel and the sites of Skul and Kavze reveal that modern humans reached Western Asia remarkably early. However, most of these pioneering groups appear to have left few, if any, significant descendants. They opened the door first, but they could not keep it open. Once again, the reason was climate. When humid periods ended, the Sahara expanded. The Arabian Peninsula became arid, and the green corridors connecting Africa with Western Asia disappeared. Water sources gradually dried up, prey declined, and many regions were already inhabited by Neanderthals. Evolutionary history shows that arriving first does not always guarantee success. Sometimes, timing is what matters most. Around 70,000 to 60,000 years ago, a favorable climate window emerged. Sea levels were lower than they are today. Coastal regions expanded, and ecological corridors formed once again. Some groups of Homo sapiens began the migration now known as out of Africa. They may have traveled through the Levant, crossed the Arabian Peninsula, or followed coastlines rich in marine resources. Archaeological sites at Pinnacle Point in South Africa show that humans were exploiting marine resources as early as around 164,000 years ago, giving them valuable survival experience before embarking on the longest journey in human history. What astonishes scientists is not the distance they traveled, but how few of them there were. DNA analysis suggests that most people living outside Africa today may descend from a very small ancestral population, with an effective breeding population of only a few hundred to a few thousand individuals. This phenomenon is known as a genetic bottleneck. In other words, the entire history of billions of modern humans may have begun with a community smaller than the population of a village today. As Homo sapiens expanded into new territories, they encountered Neanderthals in Western Asia and Europe, Denisovans in Asia, and may have coexisted with other human species in Southeast Asia. Most people outside Africa today still carry about 1 to 2% Neanderthal DNA, while many Melanesian and Papua New Guinean populations also carry an additional 3 to 5% Denisovan DNA, showing that human history is a story of intermingling, not simply replacement. Within only a few tens of thousands of years, Homo sapiens spread across Eurasia, reached Sahul, including Australia and New Guinea. By around 65,000 years ago, moved into Siberia, and eventually entered the Americas around 16,000 to 14,000 years ago. Looking back, the migration that changed world history did not begin with an empire or a conquest. It began with the quiet footsteps of a few small groups of people moving across a constantly changing planet. They had no idea that their journey would carry Homo sapiens to every continent and begin an entirely new relationship with Earth. For the first time in history, a species was not merely adapting to its environment, but was gradually approaching the ability to reshape the very planet that had created it. What set Homo sapiens apart was not physical strength, but the ability to create and pass down things that did not exist in nature. A stone could become a tool, a signal could become language, and a story could connect an entire community. Humans were not only adapting to the world around them, but also beginning to create new ways to survive within it. Scientists call this ability cumulative culture. Unlike biological evolution, which requires thousands of generations to produce change, culture allows humans to learn, improve, and pass on experience within only a few generations. A hunting technique, a method of tool-making, or knowledge about the environment could be preserved after its creator died, then continued to develop across many generations. Archaeological evidence shows that the foundations of this ability appeared very early. Fossils from Jebel Irhoud reveal that Homo sapiens existed around 300,000 years ago, with many features resembling those of modern humans. At Pinnacle Point Caves, researchers discovered evidence that humans were exploiting marine resources and using heat to process silcrete as early as around 164,000 years ago. The control of fire was one of the earliest examples. Fire allowed humans to stay warm, cook food, protect themselves, and alter the surrounding landscape. Over time, this ability opened the way for even greater transformations, including agriculture, cities, and technology. Developments that would eventually make humanity a force capable of profoundly influencing Earth's systems. However, around 300,000 years ago, Homo sapiens was still only a small species living in a world of giants. Mammoths, cave lions, migrating herds, and climatic upheavals still determine most aspects of human life. At that time, humanity's defining difference was still only a potential. The ability to transform individual experience into shared knowledge for the entire community. That ability created a new form of evolution. It was no longer only the body changing through genes, but humanity changing through ideas. An invention no longer had to wait thousands of years to spread. It could be shared, improved, and passed on to the next generation. Looking back at the dawn of humanity, the strangest thing is not that Homo sapiens survived in a world filled with danger. What is truly remarkable is that a species without claws or exceptional physical power developed the ability to transform knowledge into strength. Around 300,000 years ago, Earth created Homo sapiens. But over the thousands of years that followed, Homo sapiens would begin creating a different Earth. From this point forward, the human story would no longer be only about how we adapted to this planet, but also about how one living species began changing the very world that gave birth to it. We often think of ourselves as standing at the pinnacle of evolution, but DNA tells a different story. Humans are the result of billions of years of life's experiment. So who are we? And where did that journey begin? There was a moment in Earth's history when everything was rewritten in just a matter of hours. Before that, this planet belonged to creatures that had dominated it for approximately 165 million years, the dinosaurs. In that world, mammals were merely small creatures, living hidden in the shadows. Then, around 66 million years ago, a colossal celestial object known as Chicxulub slammed into Earth, in what is now the Yucatan Peninsula. This was not a single event, but a chain reaction on a planetary scale. The consequence was that approximately 75% of all species on Earth disappeared. The entire group of non-avian dinosaurs was wiped out. Ecosystems that had remained stable for tens of millions of years were completely shattered. But the most important thing was the void that followed. When the rulers vanished, vast ecological space opened up. The small creatures that had long been constrained mammals began entering an evolutionary experiment unlike anything before. Over the tens of millions of years that followed, mammals gradually came to occupy a wide range of habitats. One branch of them developed the ability to climb, live in trees, and eventually acquire crucial traits: forward-facing eyes, stereoscopic vision that allowed precise judgment of distance, and hands with opposable thumbs capable of grasping. These became the earliest foundations of the primates, the group of animals that would eventually lead to humans. Fossil evidence and modern ecological models point to one clear conclusion: evolution does not follow a predetermined plan. It depends on unpredictable events and moments that alter the entire direction of life. From this perspective, the asteroid was a cosmic filter, removing a world that had dominated for too long and inadvertently clearing the way for another. Without it, the history of life might have been entirely different, and the concept of humanity may never have existed. And what is truly haunting is not the asteroid's destructive power, but the entire journey that ultimately led to human intelligence. Around 60 to 55 million years ago, after the world had just emerged from the aftermath of the mass extinction, a small branch of life began to appear: the first primates. They possessed an advantage that few other creatures had at that time: the ability to live in trees. At the same time, their hands were changing as well. Opposable thumbs became more developed, allowing precise gripping force between the thumb and the other fingers. What seemed simple became the foundation for every complex behavior that followed, from grasping branches and picking fruit to using tools. A small gesture on an ancient tree branch laid the first stone for the future ability to write, build machines, and construct cities. But evolution was not occurring only in the body. It was also unfolding quietly within the brain. Life in the trees forced primates to process enormous amounts of information. Which branch was strong enough? Which root was safe? Where food could be found? And most importantly, which members of the group could be trusted? Studies of modern primates reveal an important common pattern. The more complex a species' social life is, the more developed its brain tends to be. This is known in evolutionary biology as the social intelligence hypothesis. What is remarkable is that all the abilities modern humans take pride in, from planning and building social systems to creating language, can be traced back to very specific pressures. Not falling from a branch, not being left behind by the group, and not losing access to food within the complexity of a dense forest environment. Therefore, the human brain is not a perfect design in the modern sense. It is the product of millions of years of layered adaptations, sculpted by small but repeated risks within ancient forests. And within those canopies, a unique form of intelligence began to emerge. An intelligence capable of transcending the very environment that created it. And from that point forward, an entirely new evolutionary path began to unfold. There is a very common misconception. We often think intelligence was the starting point. But the fossil record tells a completely different story. Intelligence was not what appeared first. It was the final result of survival pressures that unfolded over millions of years. Around 7 to 5 million years ago, East Africa underwent a major climatic transformation. Dense forests were gradually replaced by expanding grasslands. In the forests, animals could hide, climb, and move between tree canopies. But on the grasslands, there was no shelter, no safe escape route. Every movement could be detected from a distance. Within this context, the first human-like creatures appeared. Sahelanthropus, Orrerin, and especially Ardipithecus ramidus, a species that lived approximately 4.4 million years ago. Standing only about 1.2 meters tall and weighing between 36 and 50 kilograms, they were not the rulers of their environment. Yet they possessed a trait that would become a turning point: the ability to stand and move on two legs. What is remarkable is that upright posture appeared before the human brain began increasing significantly in size. Modern scientific hypotheses suggest that bipedal walking provided several specific advantages. By standing upright, the body reduced the amount of surface area directly exposed to sunlight, helping regulate temperature more efficiently in the hot grassland environment. As time continued to pass, an important figure emerged in the evolutionary record: Australopithecus afarensis, known through the famous fossil Lucy. Alongside it, many other species also appeared, existed in parallel, and then vanished without leaving descendants. Australopithecus africanus, Paranthropus, Kenyanthropus, all were different experiments of nature, each carrying its own solution to the same survival challenge. Then, sometime between approximately 2.4 and 1.4 million years ago, a new branch began to emerge: Homo habilis. This marked a clear turning point. For the first time in evolutionary history, a species began using stone tools systematically: the Oldowan culture. More importantly, this was the first time in the history of life on Earth that a species was not merely adapting to its environment, but was beginning to change the environment around it. There was no plan, no goal. Only life experimenting, eliminating, and continuing to push the boundaries of its own possibilities. In the history of evolution, there are fossils that do more than provide data. They completely change the way humans understand themselves. Lucy is one of them. When the skeleton of Australopithecus afarensis was discovered in Ethiopia in 1974, it was not merely an archaeological discovery. Lived approximately 3.2 million years ago. Her body stood just over 1 meter tall, with a brain measuring roughly 400 to 500 cubic centimeters, close to that of a modern chimpanzee. But what drew attention was not her size. It was the unusual combination of two traits: the ability to walk upright on two legs and a body structure that still carried traces of a climbing lifestyle. For decades, people believed that human evolution resembled a straight path, from ancient apes to primitive humans and eventually modern Homo sapiens. But Lucy shattered that model. Fossilized bones, together with hundreds of later discoveries, revealed a far more complicated reality. Evolution is not a single stream, but a continuously branching network in which multiple species coexist, compete, and disappear in parallel. Some species developed powerful jaws for crushing tough vegetation. Others adapted to arid environments. Some retained body structures more similar to those of primates. We are one of the rare results that remain. When scientists study Lucy, they recognize something even more important than appearance: a behavioral transition. Although her brain remained small, the structure of her pelvis and legs suggests that upright walking had already become relatively stable. Standing upright was a process that unfolded over millions of years, long before intelligence began expanding dramatically. This was one of the most important turning points in biological history, because it demonstrates that evolution did not prioritize intelligence immediately. It prioritized survival within a changing environment. Species that could not adapt quickly enough disappeared. Species that adapted in different ways diverged into multiple parallel evolutionary paths. Under those pressures, some branches developed stronger bodies to cope with harsh conditions, while others retained smaller and more agile forms for flexible movement. Lucy is not merely a fossil. She is a milestone within a vast network where evolution does not select the best, but simply preserves what remains suited to an ever-changing world. And from within that very network, a new turning point was gradually beginning to emerge. For most of the history of life, every organism followed a silent rule: adapt in order to survive. They were constrained by climate, food availability, predators, and natural changes beyond their control. But between approximately 2.4 and 1.4 million years ago, A small branch of the human family broke that rule, not through physical strength, but through a simple yet revolutionary act: picking up a stone and turning it into a tool. That species was called Homo habilis. Compared to the species that came before, there was nothing particularly extraordinary about their bodies. Their brains measured only about 600 to 700 cubic centimeters. Their stature was small, and they remained heavily dependent on the natural environment. Yet in their hands appeared something entirely new in evolutionary history: Oldowan stone tools, sharpened stone flakes used to cut meat, slice through hide, and break bones. This was not merely a small behavioral change. At its core, it was a profound biological turning point. For the first time, an animal species was no longer using only its body to interact with the world, but was using an external object to extend its ability to survive. These crude tools opened access to a source of energy that had previously remained largely untapped: meat and bone marrow from animal carcasses. When Homo habilis began using stones to break bones, they gained access to a far richer source of calories than a diet based solely on plants. In this case, the brain of Homo habilis gradually expanded to approximately 600 to 700 cubic centimeters, representing an important leap beyond earlier ancestors. But the most important change was not brain size itself. It was the emergence of a new evolutionary feedback loop. For the first time in the history of life, tools were not merely serving survival. They were beginning to reshape the very brain of the creature that created them. A simple yet symbolic example illustrates this shift. Rather than consuming only the soft tissues of animal carcasses, Homo habilis could use stones to crack open the femur bones of large animals and access the marrow inside, a rich source of energy-dense fat that many other predators could not easily exploit. More importantly, tool use marked the emergence of an evolutionary psychological change: the ability to imagine the function of an object. A stone was no longer just a stone. It could become a blade, a hammering tool, or a means of unlocking resources. This was the first step toward abstract thought in human history. As the number of tools increased, traces of them appeared across the landscape. Bones were split apart, animal carcasses were processed differently, and ecosystems began to feel the influence of a single species' behavior. Yet when viewed across the entirety of history, this was the beginning of a new era. An era in which organisms did not merely live within the natural world, but began restructuring it through deliberate action. And from those crudely shaped stones, another evolutionary threshold was gradually being prepared. Throughout the entire history of evolution, there have been technologies that were not invented in a single moment, but emerged from natural phenomena. Fire is one of them, the way humans came to control it. And that very moment marked the transition from a species living within nature to a species beginning to direct nature itself. Around 1.9 million years ago, Homo erectus appeared in the fossil record. This was a species that endured for more than 1.5 million years, a span of time so vast that it far exceeds the entire history of modern civilization. Archaeological evidence suggests that the use of fire may have first appeared as early as 1 million years ago, and gradually became more common among ancient human groups. At first, fire was neither a manufacturing tool nor a technology. It was a natural phenomenon, wildfires sparked by lightning, volcanic activity, or climatic events. But rather than avoiding it like other species, Homo erectus learned to preserve it, maintain it, and eventually control it. Raw meat, tough roots, and hard-to-digest tubers all became more accessible when cooked. This process not only softened food, but also broke down protein structures and eliminated many pathogens. As a result, the body spent less energy on digestion while absorbing more nutrients. As food became more energy-rich and easier to digest, the body could invest more resources into the brain. A larger brain, in turn, supported better learning abilities, improving the use of fire, hunting skills, and cooperation. And this cycle continued to amplify itself over hundreds of thousands of years. Another transformative development was the change in social rhythms. Fire was not only for cooking, it extended the hours of wakefulness each day. Instead of retreating into darkness, groups of Homo erectus could gather around the light, exchange behaviors, observe one another, and maintain social interactions for longer periods. Imagine a group of ancient humans sitting around a fire in the middle of the savannah, while darkness envelops everything beyond its glow and predators continue to lurk outside. With fire, humans could survive in colder climates where long-term habitation had previously been impossible. This paved the way for future migrations out of Africa, as ancient human groups began expanding their range across increasingly diverse environments. Although the brain of Homo erectus accounted for only about 2% of body weight, it consumed nearly 20% of the body's energy. Fire did not merely change the way humans ate, it changed the way humans existed. This was the first time a living organism was no longer completely dependent on external conditions, but began reshaping those conditions according to its own needs. And when a species can control energy, control food, and control its environment at a fundamental level, a new evolutionary threshold begins to emerge. A threshold where biology is no longer the only limitation. For a very long time, modern humans believed that we were the only remaining human species, the final pinnacle of a linear evolutionary process. But in the 21st century, a quiet revolution in biology completely shattered that picture. Not through new fossils, but through something far smaller, ancient DNA. Modern genetic data confirmed that around 40,000 years ago, the world was not inhabited solely by Homo sapiens. Living alongside us were Neanderthals in Europe and Western Asia, Denisovans in Asia, and other mysterious branches such as Homo floresiensis in Indonesia and Homo naledi in Africa. These were fully human species, existing simultaneously within the same geological period. Even more surprising is that we were not completely separate from them. Modern DNA analyses show that most people outside Africa still carry approximately 1 to 2% Neanderthal DNA. Some populations in Oceania even carry additional traces of Denisovan ancestry. This means that in the distant past, multiple human species not only coexisted, but also interbred and exchanged genes. One specific example is that Neanderthal genes in modern humans are associated with adaptation to cold climates and aspects of the immune system. This suggests that encounters between ancient human species were not merely moments of contact, but events that left biological signatures lasting to the present day. This creates a profound paradox. Our sense of uniqueness is actually only a brief moment within a history spanning millions of years. But why is Homo sapiens the only one left? The answer does not lie in physical strength. Neanderthals, for example, possessed more robust bodies, were better adapted to harsh, cold environments, and were capable of using tools of comparable complexity. The crucial difference appears to have been in the organization of society and the processing of information. Homo sapiens developed broader social networks that enabled cooperation among unrelated groups. Language became more flexible, serving not only direct communication, but also the transmission of abstract ideas. Knowledge was no longer confined to individuals or small groups, but began accumulating across generations. A clear example can be seen in the spread of technology. While an ancient human group might learn how to make a tool within a community of only a few dozen individuals, Homo sapiens possessed the ability to spread that knowledge across thousands of people over vast geographic distances. Added to this was an extraordinary capacity for adaptability. Rather than depending on a specific environment, Homo sapiens could alter behavior, tools, and survival strategies to fit a wide variety of conditions. This leads to a profound reversal in perspective. Homo sapiens is not the endpoint of human evolution, but the only surviving branch remaining after a long process of diversification followed by gradual contraction. There is a familiar assumption in evolutionary history. The species that survives until the end must be the strongest. But when we examine the fossil record and genetic evidence, that assumption begins to fall apart. Homo sapiens were not the strongest. We are the last surviving species in a competition where physical strength was not the deciding factor. Between approximately 400,000 and 40,000 years ago, Earth was home to more than one human species. Evidence from fossils and ancient DNA indicates that at least several Homo species coexisted. Neanderthals in Europe and Western Asia, Denisovans in Asia, Homo floresiensis in Indonesia, and possibly even Homo naledi in South Africa. This has been confirmed clearly through ancient DNA research conducted during the 2010s and 2020s, when the genomes of Neanderthals and Denisovans were successfully decoded. They had more robust bodies, thicker bones, and were better adapted to the harsh, cold climates of Ice Age Europe. Archaeological evidence also indicates that they produced sophisticated stone tools associated with the Mousterian culture, used fire, and showed signs of caring for the sick and elderly within their communities. If we evaluate individuals alone, Neanderthals may even appear superior to Homo sapiens in many aspects of physical survival. So why did they disappear? The answer does not lie in physical strength, but in social structure and the ability to accumulate information. Homo sapiens developed broader social networks. Their language was not used solely for communication, but also for transmitting complex information, hunting plans, manufacturing knowledge, and even stories and symbols. Meanwhile, Neanderthals appear to have lived in smaller, more isolated groups. This limited the speed at which knowledge could spread. An innovation could disappear along with a single group rather than spreading across an entire continent. A simple example illustrates the difference. If one group developed a more effective hunting technique, Homo sapiens could spread that knowledge to thousands of others throughout a social network. Genetic evidence also reveals another important truth. We did not completely replace the other human species. Modern humans outside Africa carry approximately 1 to 2% Neanderthal DNA, and some populations in the Asia-Pacific region carry additional Denisovan DNA. This means that interbreeding occurred between different human species. Rather than a simple process of elimination, human history was a far more complex web of interaction. Nevertheless, the survival of Homo sapiens ultimately led to a clear outcome. Only we remain because we were more flexible in the way we organized society and processed information. If strength does not determine who survives, then what truly defines a human being? Between approximately 70,000 and 50,000 years ago, Homo sapiens began expanding out of Africa in a major wave of migration, spreading across Asia, Europe, Australia, and eventually the Americas. Archaeological evidence from this period reveals the widespread appearance of cave art, jewelry, complex tools, and signs of intentional burial rituals. A drawing on stone was no longer just a drawing. It became collective memory. A burial ritual was no longer merely an action performed upon the dead. It became a story about existence beyond death. Homo sapiens developed the ability to create and believe in entities that did not exist in nature. yet existed within the collective mind. Over time, those entities became the foundations of the modern world. Money, nations, religions, laws, corporations. None of these are tangible objects like stone or water. Yet millions, even billions of people believe in them. And because of that, they become real in social behavior. What is remarkable is that other human species that once existed, such as Neanderthals and Denisovans, also possessed intelligence, tools, and perhaps even language to some degree. But current evidence suggests that they did not develop symbolic systems of comparable complexity on the scale achieved by Homo sapiens. But a group of Homo sapiens could become a collective intelligence greater than the sum of its individual members through shared imagined agreements. Looking back, this reveals an evolutionary paradox. Humans did not dominate because they were stronger, but because they could synchronize belief. An invisible system, yet powerful enough to reshape the behavior of an entire planet. And from this point forward, the question was no longer, who are we within nature, but rather, what have we become once we gained the ability to create reality through belief? From primitive organisms to modern civilization, this entire history of survival has been recorded in fossils, encoded within DNA, and preserved in the very structure of our bodies today. Understanding our origins is the only way to accurately locate humanity's place within this planet's billions of years-long history of life. A species granted consciousness by the universe to reflect upon itself. Our ancestors were not predators. They were the ones being hunted. No claws, not fast enough to escape, not strong enough to fight back. Their existence stood constantly on the edge of extinction. Every night that passed could have been the final night of their entire species. But through sheer willpower and the bonds they formed with one another, they found a reason to survive. So what really happened in the darkness of millions of years of evolution, on the path that eventually turned us into human? There is a truth that sounds almost paradoxical. If you travel far enough back in time, you will never find a single moment when nature suddenly declared, "This is humanity." And nowhere does that become clearer than in Africa. Around 300,000 years ago, Homo sapiens emerged, but not like a solitary flash of light in the darkness of evolution. Genetic and fossil evidence from Jebel Irhoud in Morocco, Omo Kibish in Ethiopia, and Florisbad in South Africa, approximately 260,000 years, are revealing a very different picture. Modern humans were not born in one place, but from a biological network stretching across Africa. Africa, hundreds of thousands of years ago, was not a stable land. Climate shifted dramatically between wet and dry periods, causing forests to vanish and return, grasslands to expand and contract. Ancient humans were forced to keep moving in order to survive, creating populations that became separated, then met again. Under those conditions, evolution unfolded through constant contact between ancient human groups.
The time is right. Place it here. Now, twist it slowly. Yes, that's it.
Genes did not remain still. They were exchanged, blended, and reshaped across thousands of generations. This is why modern geneticists, including researchers at the Max Planck Institute for Evolutionary Anthropology, affirm that there was no single ancestor for all humanity, but rather a large interconnected population linked by widespread gene flow. Small human groups lived scattered across savannas, open woodlands, and river margins. Yet, from an evolutionary perspective, this was an extremely effective system. It allowed humans to maintain genetic diversity, the essential ingredient for adapting to a constantly changing world. And within that network, something quiet but decisive was taking place. The human brain was beginning to change. Not through one sudden leap, but through tiny shifts across hundreds of thousands of years. The skull expanded, and regions of the cortex associated with social thinking and planning grew stronger. A lone individual could hardly survive against predators such as giant hyenas, saber-toothed cats, or ancient crocodiles. Survival meant depending on the group. But what made Africa so special in this entire story? It was the only continent where humans could develop inside a vast natural laboratory, unstable climates, varied landscapes, and intensely competitive ecosystems. Every environmental shift acted like a continuous survival test, forcing humans to keep evolving. According to the Smithsonian Institution, environmental instability in Africa was one of the major forces driving the evolution of Homo sapiens. And it was there that the true nature of evolution began to reveal itself. If you traveled back in time, you would not see humans standing at the top of the food chain. You would see a world where life was measured by the ability to survive 1 second at a time. Between about 4.2 and 2 million years ago, across the expanding grasslands of Africa, species of the genus Australopithecus appeared. They stood only about 1 to 1.5 meters tall, with small brains of roughly 400 to 500 cubic centimeters, no tools, and no weapons. Meanwhile, the surrounding ecosystem was a complete network of predators: saber-toothed cats, giant hyenas, eagles that hunted primates, and ancient crocodiles capable of dragging prey underwater in seconds. According to paleobiological research from the Smithsonian Institution, mortality rates among ancient primates, especially juveniles, may have been extremely high because of predation pressure and constantly shifting environments. Only adapt or disappear, and within that harsh world, an invisible force began shaping their bodies, not brute strength, but the ability to see farther, move more efficiently, and most importantly, live in groups. But the more profound transformation was not in the body, it was in the brain. Living in a state of constant pursuit forced the brain to develop prediction. Where prey was, how predators moved, whether the group was safe. But at that moment, they were only creatures trying to hold on to life, and then a turning point would come. Around 3.2 million years ago, a fossil discovered in Ethiopia would change how we understand ourselves. It revealed something simple, yet revolutionary. Standing upright was not merely posture, it was the beginning of the entire human future. That fossil was Lucy, and from that moment on, the journey of evolution turned in a direction from which there would be no return. Research at the Smithsonian Institution has dated Lucy's skeleton to about 3.18 million years old, preserved so completely that scientists were able to reconstruct her gait with a level of accuracy never achieved before. But what made Lucy extraordinary was the way she moved. Lucy walked on 2 legs. That may sound simple, but in evolution, simplicity is often an illusion. Because standing upright was not merely a change in posture, it was a transformation in the entire way a creature interacted with the world. When the body shifted from 4 limbs to 2, a chain reaction of consequences began. In an environment where grasslands were gradually expanding across Africa, the ability to see dozens of meters farther could determine whether a predator was detected early enough or too late. A few seconds alone could create the boundary between life and death. The hands were freed, no longer needed to support the body. They began to carry food, protect the young, and later, hold tools. This was the transition from a purely biological body to a body with extended functions. Studies in locomotor biology suggest that walking on 2 legs, under many terrain conditions, can require less energy than 4-limbed movement in primates. Studies in locomotor biology suggest that walking on 2 legs, under many terrain conditions, can require less energy than four-limbed movement in primates. The pressure from predators in African ecosystems did not disappear. On the contrary, it grew stronger as grasslands expanded. That forced Australopithecus species to become more flexible in movement and survival. Then something even more important appeared. The separation between the body and the tools of survival began to form. Once the hands were no longer locked into locomotion, they could be used in entirely new ways. This became the foundation that, millions of years later, would allow Homo habilis to create the first stone tools. But Lucy was not just an individual. She represented a systemic turning point in evolution, from a creature completely dependent on the body to a creature beginning to expand its abilities through behavior. According to Nature Communications, the evolution of upright walking was one of the most important anatomical changes, directly influencing the pelvis, spine, and even the way energy was used in the bodies of early humans. And from there, the journey of evolution would enter a new age, where stone was no longer only stone, but became a tool of intelligence. And when humans first learned to turn the physical world into instruments of survival, it would be with Homo habilis. Between about 2.4 and 1.4 million years ago, within the same harsh ecosystem where Lucy once lived, a new evolutionary branch appeared in Africa. Paleoanthropologists call them Homo habilis, the handyman. It was a revolutionary biological leap. Intelligence began to directly intervene in matter. According to evidence from Olduvai Gorge in Tanzania, the earliest stone tools, dated to around 2.6 million years ago, have been found there. This was the Oldowan tool culture, simple chipped stones, yet extraordinarily powerful in practical use. For the first time in the history of life, a species did not change its body. It changed external objects to compensate for its own weakness. Now, it was no longer muscle or fangs, but thought. And this was the first moment we can truly call technology. They still lived in the same predator-filled ecosystem. Giant hyenas, saber-toothed cats, eagles that hunted primates. And under that pressure, something crucial began to happen. The human brain no longer only reacted, it began to plan. This was a very early form of cause and effect thinking, but one of immense importance in cognitive evolution. Studies of brain volume show that Homo habilis had a larger brain than Australopithecus, though still far from that of modern humans. Yet size alone did not determine everything. Here, the human hand began to change roles, no longer only an organ for movement or grasping. It became the interface between thought and the material world. A stone could now become a knife, a hammer, a tool. And from that moment, a new loop began. Tools improved survival. Better survival allowed greater brain development. Greater brain development created better tools. This was the starting point of what we now call cultural evolution. And once tools had appeared, the next step was to move farther, occupy more environments, and begin turning the entire planet into a space for survival. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . That was when a new human species emerged, stronger, more flexible, and for the first time capable of leaving the place where it was born. That species was Homo erectus, and the journey to conquer Earth had begun. Paleobiological evidence shows that Homo erectus appeared around 1.9 million years ago and survived for more than 1 million years, one of the longest-lasting human species ever known. They were the first humans to leave this continent and begin a migration on a planetary scale. Their remains have been found in Georgia, Dmanisi, China, Indonesia, Java, stretching from Africa into Eurasia, opening an entirely new age, the age of expanding human living space. But what allowed them to travel so far, while earlier ancestors remained limited by their environments? Homo erectus had a body structure far closer to modern humans than Homo habilis, longer legs suited for long-distance walking. A skeleton stronger, yet more compact, helping reduce energy use during movement. This was not a minor change, but a biological design built directly for endurance. According to research from the Smithsonian Institution and fossil analyses at Dmanisi, Homo erectus possessed extraordinary climate flexibility, adapting from the hot, dry grasslands of Africa to the temperate regions of Eurasia. But what truly made Homo erectus a turning point was the way they used tools. If Homo habilis had only begun to chip stone for survival, Homo erectus advanced to another level. Acheulean tools, hand axes crafted with symmetry, sharpness, and clear purpose. And from this point, something never before seen in evolutionary history began to emerge. Humans were not merely adapting to Earth, they were beginning to occupy it. Archaeological evidence suggests Homo erectus was capable of group hunting, constant movement in search of food, and living across more varied environments than any primate before them. Yet, despite being stronger and more intelligent, they still lived in an unfinished world. If you trace the entire journey back to Homo erectus, something strange emerges. Humans had already traveled far beyond Africa, had tools, and possessed remarkable endurance, yet they were still constrained by something invisible. They were still dependent on darkness, dependent on daylight, dependent on air that was warm enough, food that was soft enough, and most importantly, they still had to flee when the sun went down.
The shadows grow long. We must be ready.
Until something appeared and changed the entire rulebook of life: fire. Archaeological evidence suggests that the stable control of fire may have emerged as early as around 790,000 years ago, based on findings at Gesher Benot Yaakov, Israel, where scientists discovered ash remains, burned seeds, and stone tools altered by heat. At first, fire was dangerous, but very quickly it became the most powerful survival tool humans had ever possessed. A piece of raw meat might take hours to chew, but with fire, it became softer, safer, and richer in energy. That meant humans no longer had to spend all their time eating. They began to have extra time. And this is the point where evolution took an entirely new turn. Time was no longer spent solely on survival, it began to be spent on thinking. Fire also erased the fear of darkness. Humans transformed darkness into a space they could control and began to redefine it, and more importantly, around those flames, a behavior never before seen in nature began to emerge. Storytelling.
They showed us the path to the valley.
No fossil evidence records the sounds of the first stories, but social behavior strongly suggests it almost certainly happened. When a group of humans sat around a fire, their brains were no longer processing only danger. They began to build shared memory, exchange experiences, and transmit information. This was the first step of culture. Fire was changing the way humans connected with one another. Some evolutionary researchers, such as Richard Wrangham from Harvard, argue that cooking food with fire was the key factor that increased brain energy, thereby driving the development of social structures and language. It would reshape the entire picture of human evolution, and that is when the lost brothers began to appear. Before Homo sapiens became the only surviving human species, Earth was not home to just a single lineage of humanity. And among those lost branches, two in particular continue to challenge modern science, like a puzzle still missing its final piece: the Neanderthals and the Denisovans. These were not mythical beings. Neanderthals lived roughly between 400,000 and 40,000 years ago, primarily across Europe and Western Asia. Denisovans, on the other hand, remain far more mysterious, known only through a handful of bone fragments and DNA discovered in Denisova Cave in Siberia, Russia. They were extraordinarily well adapted to their environments. Neanderthals had short, powerful bodies, exceptionally strong musculature, and skulls that, on average, were larger than those of Homo sapiens. Some studies suggest their brain volume was comparable to, or even greater than, that of modern humans. They lived through the Ice Age, in conditions where temperatures in Europe could plunge below -20 degrees Celsius. They hunted mammoths, woolly rhinoceroses, and massive deer using coordinated group strategies. They controlled fire, crafted sophisticated Mousterian stone tools, and showed evidence of caring for the injured, something typically seen only in structured, socially complex groups. Denisovans left behind far fewer traces, but their DNA reveals a vast range, from Siberia to Southeast Asia. Even today, some modern populations in Melanesia and Tibet carry up to 3 to 5% Denisovan DNA, associated with adaptations to high altitudes and extreme environments. Around 60,000 to 40,000 years ago, Homo sapiens began migrating out of Africa and expanding across the globe. And when these human species encountered one another, they did not simply compete, they interbred. Modern genetic evidence shows that most people outside Africa today carry about 1 to 2% Neanderthal DNA. But why did only Homo sapiens endure? Homo sapiens developed the ability to expand social groups to hundreds, even thousands of individuals through shared language and collective belief. While Neanderthals may have been powerful yet scattered, Homo sapiens began building something entirely new: communities of ideas. And when we look back, we realize something profound. We are no longer a pure species. We are the result of blending, collision, and convergence among multiple ancient human lineages. If many human species once coexisted on Earth, what determined that only one would continue? Around 70,000 years ago, Earth did not change its shape. No asteroid struck. No global catastrophe was recorded. And yet, something profound happened, what science now calls the cognitive revolution. Archaeological and genetic evidence suggests that during this period, Homo sapiens began to display entirely new behaviors: complex language, symbolic expression, art, and abstract thought.
The hunter told us of a great beast.
Wow.
It is larger than the elders remember. We must prepare for the hunt.
After this turning point, they began to create new worlds within the mind. For the first time, something that did not physically exist could shape survival itself.
Look to the stars. They show us the path. We must follow the light, even when the shadows are long.
In caves such as Chauvet in France and Sulawesi in Indonesia, ancient paintings appear dating back over 30,000 to 40,000 years. Images of animals, handprints, and abstract symbols.
Notice the unique pigments here, unlike anything we've seen before. Yes, the detail is extraordinary. Look at the shading. See how it connects?
These images created shared meaning when a group of people could look at a symbol and understand the same idea. A new structure emerged, not biological, but social, and yet powerful enough to influence the behavior of hundreds at once.
We will be ready.
Humans began to live in two worlds simultaneously. One was the physical world, filled with danger, predators, and harsh climates. The other was an invisible world, constructed from memory, belief, and imagination. Humans began to believe that we mattered more than I. And to sustain groups of that scale, they created another invisible system: laws. Laws do not exist in nature. They leave no physical trace in stone or soil. And yet, they guide behavior more powerfully than instinct itself. Then came an even greater leap: gods, not born from ignorance, but from the need to unify belief among strangers. This was an evolutionary invention of social cohesion. And when these invisible systems came together,
The mountain
language,
spirit awakens. We must make the offering before the moon sets. Silence. We will not be rushed.
belief, law, and symbols, something entirely new emerged.
Today
The
we
early
shared the
civilization of
mammoth
ideas.
Tomorrow we share the work.
It is good this way.
No longer confined to Africa, no longer limited to a single region, humans began to leave their cradle. A migration unlike any in the history of life was about to begin, and when it did, Homo sapiens were no longer just a local species. They became the first global species. This was the beginning of Out of Africa, a conquest of Earth not driven by weapons, but by adaptability and imagination. Modern genetic and archaeological evidence shows that Homo sapiens began leaving Africa in a major wave around 70,000 to 50,000 years ago, moving through the Arabian Peninsula into the Middle East, and eventually spreading across the vast expanse of Eurasia. But imagine that first moment they stepped beyond Africa, not as a migration, but as a leap into a world completely unknown. Only shifting climates, expanding landscapes, and territories the human body had never adapted to. Around 65,000 years ago, evidence of humans appears in Australia. To reach it, they had to cross open seas, one of the earliest maritime journeys ever undertaken by our species. This means that even without modern boats, without complete star maps, humans were capable of crossing oceans through a combination of observation, memory, and courage. Then, around 15,000 to 20,000 years ago, humans set foot in the Americas via the Bering Land Bridge. During the last ice age, when sea levels were tens of meters lower than today. Humans crossed scorching deserts where temperatures could exceed 50 degrees Celsius. They moved into Siberia, where winters could fall below minus 40 degrees Celsius. They lived in humid tropical rainforests, where disease and moisture became invisible enemies. They climbed into the high Himalayas, where oxygen thins dramatically with altitude. No other primate had ever expanded its range in this way. This did not happen because the human body was perfect. Homo sapiens did not evolve to fit one place. They evolved to change how they live, depending on where they go.
Over here.
And that flexibility is rooted in everything that came before. From the stone tools of Homo habilis, from the fire mastered by our ancestors, from the Neanderthals we once interbred with, and from the cognitive revolution that turned ideas into tools for survival. But there is a paradox. The farther humans spread, the more different they became in appearance, skin color, and culture, yet the more alike they remained at their core. If humans were able to spread across the entire Earth in just tens of thousands of years, what happens when we are no longer confined to Earth? Each step forward was not an instant upgrade, but a survival response to environment, to hunger, to cold, and to the deep uncertainty of nature itself. Around 1 to 2% of the DNA in many people outside Africa comes from Neanderthals, and portions of Denisovan DNA still exist in populations such as those in Melanesia and Tibet. This means that we are not a single, straight line that outcompeted all others, but a complex hybrid result of multiple human lineages that once coexisted on this planet. When you look back across the entire journey, from Lucy walking the African savanna, to Homo erectus leaving the continent, to fire, to the lost human lineages, and finally to the cognitive explosion, you begin to see something strange. Human is not a destination, but an ongoing process. And if that is true, then the next question is no longer, where did we come from, but what are we becoming? Because evolution has never truly ended, it is simply shifting into a new form, where technology, artificial intelligence, and human consciousness itself are beginning to act as the next evolutionary forces.
Over there. Look. Look. I see it. Let's go.
The strangest thing in Earth's history is not the rise of humans, but that only one human species survived. Homo sapiens were never the strongest. fastest, or most numerous. So why did every other human lineage disappear, while we became the dominant species on Earth? Around 7 million years ago, the last common ancestor of humans and chimpanzees split into two different evolutionary branches. From that moment on, the history of the human family was nothing like a ladder with step after step rising upward, as many old textbooks once described. Some species appeared and then disappeared. Some species coexisted for hundreds of thousands of years. Homo sapiens was only one of many branches that once grew from that bush. What created that complex evolutionary network? Over the last 3 million years, the climate of this continent repeatedly shifted between wet and dry periods, driven by changes in Earth's orbit combined with global climate transformations. Dense forests shrank and expanded many times. Savanna grasslands spread far and then gave way to trees again. Lakes formed and then vanished. Imagine a community living around a large lake in East Africa. When a long drought arrived, the lake slowly dried out. One group had to move north, another moved south, while others crossed toward the west. Tens of thousands of years spent living in different environments caused them to accumulate their own genetic traits. That is why more and more paleoanthropologists support the Pan-African origin model. According to this model, Homo sapiens was not born in a single cradle in East Africa, as the traditional view suggests, but formed from a network of ancient human populations spread across Africa, constantly connecting and exchanging genes with one another. Archaeological discoveries over the past 2 decades have strongly reinforced that picture. In 2017, scientists announced fossils from Jebel Irhoud, Morocco, dated to around 315,000 years ago, now considered among the oldest known Homo sapiens fossils. What is astonishing is that this site lies more than 3,100 miles, or about 5,000 kilometers, away from the regions of East Africa. Meanwhile, the Omo I fossil in Ethiopia has been dated to about 233,000 years old, while Herto is about 160,000 years old. Genome analyses of thousands of modern people show that Africa today still has the highest level of genetic diversity in the world, reflecting a long evolutionary history in which many populations once lived apart and then repeatedly blended together. And yet, if we could meet the first Homo sapiens, we might be surprised by how familiar they looked. They already had relatively flat faces, skulls that were rounder than those of earlier Homo species, bodies adapted for long-distance walking, and hands skilled enough to make refined stone tools. They knew how to hunt, gather, exploit many food sources, and survive in very different environments. However, for tens of thousands of early years, they were still only one human species among many others. If modern appearance, skillful hands, and the ability to make tools were still not enough to help Homo sapiens dominate the planet, then what created the turning point? For decades, scientists once believed that the larger the brain, the higher the intelligence. But fossils have told a completely different story. The brain of Homo sapiens today has an average volume of about 82 cubic inches, or around 1,350 cubic centimeter, while many Neanderthal individuals reached between 88 and 98 cubic inches, or about 1,450 to 1,600 cubic centimeter. And yet, around 40,000 years ago, they disappeared, while Homo sapiens spread across almost every continent. That shows the decisive factor was never simply a larger brain. The skull of Homo sapiens tends to be rounder, reflecting a restructuring of the brain during development, especially in the parietal region and the cerebellum, areas linked to information integration, planning, memory, and the coordination of complex cognitive activities. However, Homo sapiens seems to have possessed a special advantage: the ability to connect many separate ideas and create entirely new concepts. Homo sapiens could sit around a fire, imagine a hunt that would take place many days later, predict that a herd of antelope would move with the seasons, calculate how much water to carry, and divide tasks among each member before the hunt began. Imagine a group of hunters around 70,000 years ago. They did not chase after prey the moment they saw it. They observed footprints still pressed into the ground from the day before, read the direction of the wind, chose an ambush point many miles away, and then waited patiently. But the greatest wonder lay in another ability: symbolic thinking. Homo sapiens began to see more than what their eyes could observe. Archaeological evidence at Blombos Cave in South Africa shows that from around 75,000 to 100,000 years ago, Homo sapiens had carved geometric patterns onto ochre and made shell beads to wear on their bodies. These objects did not make hunting more efficient, nor did they create more food. Their value lay entirely in symbolic meaning. It was a sign that humans had begun to think beyond the physical world in front of them. From that moment on, the human brain did not only remember facts, but also created invisible realities. Rules, honor, belief, gods, and later money. nations, and science could not be held, weighed, or measured. This was one of the most important turning points in evolutionary history. Homo sapiens could connect much larger communities through shared symbols and shared beliefs. That variability opened the way for division of labor, trade, religion, states, and eventually the entire civilization of humanity. However, for the cognitive revolution to truly change history, those thoughts had to be transmitted with increasing accuracy from one brain to another, from one generation to the next. And that was when Homo sapiens possessed the most powerful technology ever to appear on Earth: language. This was not merely a tool for communication. It was the first technology that allowed knowledge to be stored, copied, and improved without waiting for genetic mutations to accumulate over thousands of generations. Humpback whales sing songs that can last for tens of minutes and travel for dozens of miles through the ocean. Honeybees perform the famous waggle dance to indicate the direction and distance of flowering plants. Vervet monkeys produce different alarm calls when they spot eagles, leopards, or snakes, and each sound triggers a distinct response from the entire group. These systems are remarkably sophisticated, yet they all share the same limitation. They primarily communicate what exists here and now. Humans can recount a hunt that took place years earlier, describe a valley hundreds of miles away, warn of a danger that has not yet appeared, or discuss an idea that has never existed in the physical world. This trait is nearly unique within human communication systems and forms the foundation of all long-term planning. A few spoken sentences could transfer experiences accumulated over many days to listeners who had never lived through them themselves. For the first time, knowledge became separated from personal experience. A stoneworker who discovered how to strike two different types of rock to create a sharper blade no longer had to carry that secret to the grave. He could teach it to his descendants, pass it on to others in the tribe, and generations later it could be refined into spears, javelins, or arrows. In evolutionary biology, this phenomenon is known as cumulative culture. But the greatest power of language was something even more extraordinary. It allowed humans to tell stories. What bound people together was no longer blood alone, but shared narratives. Who their ancestors were, who owned the land, which rules must be followed, and why people were obligated to protect one another. More importantly, everyone believed in those stories. That became the foundation of every human society that followed. The archaeological record reflects this transformation with remarkable clarity. From roughly 100,000 to 40,000 years ago, Archaeologists observed a dramatic increase in jewelry, pigments, beads, cave art, figurines, and burial rituals across many regions of Africa, Western Asia, and later Europe. Even more remarkable is the fact that the brains of modern Homo sapiens are almost indistinguishable from those of their ancestors who lived approximately 40,000 years ago. Yet for the first time in Earth's history, knowledge became a form of inheritance more powerful than DNA itself. And once knowledge could be accumulated, corrected, and passed forward, rather than endlessly restarted from the beginning, a new force emerged. Faster, more flexible, and powerful enough to shape an entire planet. Cultural evolution. It was this force that would carry Homo sapiens out of Africa and begin the conquest of nearly the entire world. For nearly 4 billion years in the history of life on Earth, every species had to adapt by the same rule. Wait for random genetic mutations to appear, then let natural selection decide which mutations would be preserved. But with Homo sapiens, another path appeared for the first time. Instead of only changing the body, humans began changing knowledge. And what is astonishing is that knowledge can evolve far faster than DNA. Anthropologists call this phenomenon cumulative culture. The archaeological record shows that from roughly 100,000 to 50,000 years ago, the pace of technological innovation among Homo sapiens began to increase noticeably. Stone toolkits no longer remained unchanged for tens of thousands of years as before, but became increasingly diverse and specialized. Long blades appeared, along with smaller but sharper spear points, tools for processing animal hides, woodworking tools, and many sophisticated stone knapping techniques. Around 45,000 years ago, in Siberia and many sites across northern Asia, archaeologists discovered bone needles with eyes for threading. Only about 2 to 3 inches long, this tiny artifact marked an enormous revolution. Instead of merely wrapping animal hides around the body, Homo sapiens could cut, sew, and create clothing that fit closely to the body, trapping a warm layer of air inside. Thanks to this, they could survive in regions where winter temperatures could fall below -22 degrees Fahrenheit. But culture did not only create tools, it also created identity. Around 51,000 years ago, Homo sapiens reached Australia. Even though this continent was never fully connected to Asia, not even when sea levels were at their lowest during the Ice Age. That means they had to cross straits dozens of miles wide using floating vessels they had built themselves. This was not simply a technical achievement. It was the result of knowledge accumulated across countless generations. Alongside technological development came an explosion of spiritual life. The paintings in Chauvet Cave in France, dated to around 36,000 years ago, or the artworks on Sulawesi Island in Indonesia, at least 51,200 years old, show that humans were no longer concerned only with food and shelter. They began telling stories through images, preserving memory, passing down experience, and building communal identity. The remarkable thing is that over the past roughly 40,000 years, the genome of Homo sapiens has changed relatively little, while technology and culture have developed at an unprecedented speed. For the first time in the history of life, a species could adapt to its environment much faster by changing behavior rather than changing the body. This was the greatest advantage Homo sapiens had over every other human species. And precisely when culture began to evolve faster than genes, Homo sapiens possessed the final condition needed to carry out the boldest adventure in human history, leaving Africa and turning nearly the entire planet into their home. Around 70,000 to 60,000 years ago, a relatively small group of Homo sapiens began leaving Africa, possibly through the Sinai Peninsula or the Bab el-Mandeb Strait region of the Red Sea. Earlier waves of Homo sapiens had already left Africa before this, such as the fossils at Mislia and Skul Kavze in Israel, which show that humans were present outside Africa from roughly 180,000 to 120,000 years ago. Genetic models estimate that the founding population may have included only around 1,000 to 10,000 breeding individuals, and the number of people directly involved in each stage of migration may have been much smaller. Those footsteps quickly spread with astonishing speed. Around 65,000 years ago, Homo sapiens were already present in northern Australia. This is especially important because Australia was never connected to the Asian mainland, even when sea levels were at their lowest. That means humans had to cross straits at least about 45 to 60 miles wide, using deliberately prepared floating vessels. Around 45,000 years ago, Homo sapiens entered Europe, where they faced freezing winters and inhabitants who had lived there for hundreds of thousands of years. The Neanderthals. Farther east, human groups continued into Siberia, where winter temperatures could drop below -58 degrees Fahrenheit. They wore multiple layers of animal hides sewn tightly with bone needles, built shelters, stored fuel, and coordinated hunts of mammoths and reindeer. The peak of this expansion took place near the end of the Ice Age, when enormous amounts of water were locked inside ice caps, and global sea levels were about 390 feet lower than today, exposing a vast landmass called Beringia, which connected Siberia to Alaska. Around 20,000 to 15,000 years ago, groups of Homo sapiens crossed this land bridge or moved along the Pacific coast to enter the Americas. What is most astonishing is the number of environments they conquered. From tropical rainforests, African savannas, Arabian deserts, and the Tibetan Plateau to the subarctic, Homo sapiens found ways to survive through knowledge instead of waiting for their bodies to change. At this point, it seemed as if Homo sapiens had become the human species that dominated Earth. But when they set foot in new lands, they quickly discovered a surprising truth. This planet did not belong to them alone. In Europe, there were Neanderthals. Across many regions of Asia, there were Denisovans. And on isolated islands, other human species still existed, each with its own evolutionary history. After a migration that lasted tens of thousands of years, Homo sapiens finally reached nearly every habitable region on Earth. The strange thing is that only about 40,000 years later, all of those branches disappeared from the fossil record, leaving behind only one name: Homo sapiens. The most famous were the Neanderthals, who appeared around 400,000 years ago and dominated Europe and Western Asia through many Ice Age cycles. They were short but extremely powerful, with broad chests, thick bones, and short limbs that helped them retain heat efficiently in cold climates. They knew how to make fire, crafted tools using the highly sophisticated Levallois technique, hunted bison, wild horses, and mammoths in groups, cared for injured individuals for years, and left evidence of burial rituals. Meanwhile, in Siberia, science uncovered an even stranger story. In 2008, at Denisova Cave, archaeologists found only a fragment of a finger bone and a few teeth. To the naked eye, it was almost impossible to know who they belonged to. But DNA sequencing technology created a turning point. Results published in 2010 showed that this was an entirely different human branch, now known as the Denisovans. Evolution on islands created other surprises as well. On the Indonesian island of Flores, scientists discovered Homo floresiensis, only about 3 feet 6 inches, 1.06 meter, tall, yet still capable of making stone tools and hunting animals. On the Philippine island of Luzon, fossils of Homo luzonensis further proved that only about 50,000 years ago, Earth was not the planet of a single human species, but a place where many human branches coexisted, each representing a different evolutionary path. Denisovans also left a similar genetic mark in many Asian and Oceanian populations. They did not completely disappear. Part of them is still living inside the genomes of billions of people. However, interbreeding is not enough to explain the whole story. DNA studies also show that they experienced long periods of low genetic diversity, which made their ability to recover from natural disasters, disease, or declining prey more limited. By around 40,000 years ago, Neanderthals disappeared from the fossil record. Denisovans, Homo floresiensis, Homo luzonensis, and other human branches also gradually left the stage of evolution. After nearly 7 million years since the human lineage split from its common ancestor with chimpanzees, the evolutionary bush that once had so many branches now had only one surviving branch left. From that moment on, Homo sapiens no longer had to compete with any other human species. And from here, instead of merely learning how to adapt to the world, humans would begin moving into a far bolder stage, changing the world itself to serve them. Around 11,700 years ago, when the last ice age ended and the Holocene began, Earth entered a rare period of climate stability. Giant glaciers melted. Sea levels rose about 394 feet compared with the glacial maximum. And forests and grasslands expanded across many continents. For the first time, environmental conditions were stable enough for a bold idea to emerge. Instead of continuing to chase food, why not make food stay with humans? Around 12,000 to 10,000 years ago, in the Fertile Crescent of Western Asia, humans began selecting wild wheat and barley plants with favorable traits for cultivation. What is interesting is that agriculture did not appear in only one place. Around the same time, other communities in the Yangtze and Yellow River basins developed rice and millet farming. In New Guinea, taro and bananas. In Mesoamerica, corn, beans, and squash. And in many parts of Africa, sorghum and millet. Humans also began changing the animals around them. Creatures that had once appeared only as prey now became stable sources of food, milk, hides, wool, and pulling power. This was the first time in the history of life that one species did not merely adapt to an ecosystem, but redesigned the ecosystem according to its own needs. Forests were cut down to open fields. Wetlands were redirected into irrigation systems. Plants and animals were selected over many generations, gradually becoming very different from their wild ancestors. As food became more stable, human groups no longer had to keep moving. The first villages appeared, then gradually grew into towns and cities. At first glance, this seemed like the perfect victory of Homo sapiens. But archaeology tells a more complicated story. Analyses of thousands of skeletons from the early farming period show that the average height of many communities declined compared with their hunter-gatherer ancestors. Diets dependent on only a few crops made nutrition less diverse. Another paradox also quietly appeared. When land could be owned, wealth could be accumulated, and food could be stored, society began to divide. Humans traded the freedom of the hunter-gatherer life for the stability of agriculture, traded relative equality for productivity, surplus, and the complexity of civilization. Yet, on the scale of the entire planet, this revolution changed Earth in an unprecedented way. The human population rose from a few million to tens of millions, and then to hundreds of millions. Forests became fields, rivers were diverted, wetlands were reclaimed, and trade networks connected lands thousands of miles apart. And it was the distance between a Stone Age brain and an increasingly complex civilization that would lead Homo sapiens to a moment when human power was no longer limited to changing the environment, but began expanding toward changing the very future of its own evolution. But the farther we move forward, the more we discover a strange paradox. The world has changed at breathtaking speed, while the brain that created all of it has remained almost the same. If we look at the skull of a Homo sapiens who lived around 40,000 years ago, it is very difficult to distinguish it from the skull of a human today. That does not mean the brain has not changed at all. But the biological changes are very small compared with the speed of civilization's development. Since the agricultural revolution began around 12,000 years ago, humanity has passed through only approximately 400 generations. A span of time far too short for natural selection to significantly restructure the most complex organ in the body. On the African savanna, a strange sound in the bushes or the footprint of a predator could determine survival. So the brain evolved to pay special attention to things that were new, unexpected, and especially dangerous. In the 21st century, That same mechanism makes it difficult for us to take our eyes off our phones. This does not happen because humans lack willpower, but because digital platforms are exploiting neural mechanisms that were formed hundreds of thousands of years ago. In ancient environments, missing a predator could mean death, while missing a beautiful scene had almost no consequence. So the brain prioritized detecting danger above everything else. Today, when news from around the world appears continuously on screens, the brain still reacts in the old way. A single headline about war, natural disaster, or crisis can attract attention more powerfully than dozens of positive stories. Another mechanism that once helped our ancestors survive is the tendency to prioritize people who belong to our group. But in a society connected by more than 8 billion people, that mechanism sometimes contributes to polarization, prejudice, and the spread of misinformation. The brain did not evolve to process thousands of opinions every day from people it has never met. And it was certainly not designed to face social pressure from millions of people on the internet. The brain shaped in the Stone Age did not only help humans survive, it also built telescopes to explore the universe, decoded the human genome, created quantum computers, and developed artificial intelligence. And now, for the first time in nearly 300,000 years of human history, technology is no longer only changing our living environment. It is beginning to turn toward our own bodies and brains. Are we preparing to create an entirely new kind of human? From a small group of hunter-gatherers in Africa to a global civilization, Homo sapiens was not the strongest, the fastest, or the smartest species in any single sense. Every turning point in the history of Homo sapiens opened new opportunities, but also created challenges never seen before. Today, facing climate change, artificial intelligence, synthetic biology, and the journey into space exploration, we once again stand at another crossroads of evolution. For roughly 300,000 years, Homo sapiens did not win because we were the most perfect species. We won because we are the species that never stops learning, cooperating, and changing. Perhaps the greatest wonder is not how Homo sapiens rose, but that this story is still being written by us. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.